Hey, how's it going, guys? It's January 30th, 2018, and if you've been to the site in the last few days, you saw my little video talking about what I plan to do for this off season, and one of those things was do some more info videos. So, one of the things I want to talk about is again doing another video on using these models to do some forecasting for your hunts. I do plan to get out and do some scouting and do some sort of talks about how different terrain features are affected by different weather and stuff like that. And that will be coming soon. Plan to get out either this week or next week on some public land and check out some spots that I think are probably holding some good bucks and try to find some sheds and do all that. So that's coming up soon. But in the meantime, I wanted to check this out. So now let's just pick a random spot on the map here. Now, there's three things I normally look at, and that's temperature, wind, and whether or not it's going to rain or slash snow, depending on what time of the year it is and where you're at. But, you know, I'm still on the fence about the whole pressure thing. Some people have made some points to me that were valid points, and I just really don't have the knowledge to refute them, to be honest. But um, it's possible that deer sense pressure in some way. I have yet to wrap my brain around how that could be possible, but maybe it is. So I guess we can get into about how to look at pressure too, if that's something you're interested in. I'll go over that as well. But I'm actually originally from Oklahoma, even though I live in Wisconsin now. And so it's actually fairly warm down there right now compared to where I'm at. But if say I'm going hunting in the morning in Oklahoma, and first thing I would do is go to either the NAM or the GFS and pull up the temperature forecast. Now you're going to want to select the most recent model run that's up to date. This is the most recent one, but it's only come out to 3 hours. It's still loading up. So I'm going to go to the most recent one, pick your sector view, and come down here to wherever you live. And actually, before I do that, I like to look at the large scale. You see we got a big low pressure system up here. And the way, if it's not obvious to you when you first see it, there's a couple ways you can pick out if there's a low pressure system. One is that you have these isobars that are really tightly packed. Isobars just means lines of constant pressure. And you'll notice that they get bigger. The black numbers get bigger as you come out from the center of the packed isobars. That's one way that you can tell that there's a low pressure. But also, if you look at the wind barbs, they're actually spinning around it counterclockwise. And that's typical in the northern hemisphere. When you have a low pressure, you're going to have wind spinning counterclockwise around it. So there's a big low pressure system over south central Canada. I guess that's south central Canada, maybe southwest Canada, I don't know. And it's trekking along the border pretty much. And low pressure systems this time of year are always going to drag cold air down on their western side. They're going to drag it southward, and that's because the low pressure is pulling air from the north down this way from its western side and northwestern side. And there's a couple things that determine how far that cold air is going to go. It depends on how strong the low is and where the low actually moves to. This one's moving mostly from west to east, so it's not going to drag it super far south right off the bat, unless there's a big high pressure behind it that keeps pushing that cold air farther south, or another low pressure system that comes through and drags it even more. But this one's a fairly strong cyclone. It's like a 994 low right there, which is pretty. It's actually a 990 in that frame. It's pretty stout. But so it's definitely going to be pulling some air pretty good from its north and west side. Excuse me. But so let's run this forward as it moves off. And you can see that it didn't just shunt a bunch of air southward like some cyclones do. It kind of hangs out there on the border for a day and a half, and then as it moves off, this high pressure behind it really kind of gets things going and keeps pushing it farther to the south and east. But again, if this cyclone had taken a more southward track, it would have dragged this air way down in here and gotten most of the country pretty cold. But since it goes from west to east, it kind of drags that air off to the south and east. And let's see if we can get another one to pop up on the GFS real quick so I can give you another example. See, this one actually, the GFS actually takes that cyclone. Well, nah, never mind. It's about the same track. Yeah, it does pretty much the same thing. But let's see, there should be another one form to the northwest. Yeah, there's one that formed up there, but it's way up there, so unfortunately on this model run, don't think I'm going to have that example for you. Maybe we can go back to yesterday. Okay, so here's one. Here's a weak low kind of starting to form here up in the Dakotas, and it's kind of oblong right here. You can see it's got two centers there, and it's starting to pull some air. It's not real strong. I mean, it's not deep at all. It's 10-10, which is pretty weak compared to the one we were just looking at. But you can see it's kind of starting to pull some air from the north, and it actually goes more south than the other one did. And you'll see, whoops, kind of jerked there. You'll see when it did that, it kind of dragged this little bulge down to the south with it. But then it actually moves up into the northeast, and then you have this massive high pressure behind it that's pushing all the rest of that air down to the south. So, but that's a different story. So I like to look at the large scale of things. For this, or for today, the grand scheme of things is some cold coming from for the northern part of the country, Great Lakes, northeast, maybe parts of the southeast. And then another cold front coming in behind it a few days later. But, I'm going hunting tomorrow, so I'm interested in Wednesday's forecast. And if I'm in Oklahoma, looks like, I don't have much else going for me besides southerly winds. Cold front's not going to make it here until, looks like Friday morning. So I don't have that working for me. But now that I've looked at the large scale of things, I'm going to go to the Southern Great Plains sector view so I can get a better look at this. And I'm actually going to go to the HRRR. This is the High Resolution Rapid Refresh. Meteorologists call it the HRRR. Real clever. But this is just a really high resolution model. Basically, what that means is you have a lot more data points than you do on like the GFS and the NAM. The GFS and the NAM have grid spacing, what they call grid spacing of 12 kilometers, which means you have boxes of 12 kilometers worth of data, or 12 kilometer boxes of data, and that's fairly coarse resolution. And then if you go to something like the HRRR, I think it's 3 kilometer resolution, so your boxes are 3 kilometers wide on the actual map. And you can think about it, if you were going to make a picture or something, it's basically the difference between making a picture where the pixels are 6 inches wide, and then a picture where the pixels are an inch wide. Obviously, your picture with pixels that are an inch wide is going to be a lot clearer than the one with pixels that are 6 inches wide. It's the same concept pretty much. If you talk to a modeler, they're going to give you a lot more complex explanation than that, but that's basically how it goes. So I like to look at this for basically day of forecasting for my winds and my relative temperature. And if you haven't heard me talk about it before, these are wind barbs. And basically, you have, I can pull up a diagram of wind barbs real quick. What? That is not what I wanted. Okay, so here's what they look like. Shows the different speeds. Now, if you don't know how to read knots, I mean, it's relatively similar to miles per hour. I want to say 1 knot is like 1.2 miles per hour. Yeah, 1.15, so 1.2. I mean, when I look at this, for deer hunting at least, I mean, for doing weather forecasting, it's a little different, but for deer hunting, you know, if I see this and it says 15 knots, I'm gonna think, okay, 15 to 20 mile an hour winds, basically. That's the way I go about that. And so if I'm looking at this, I would be hunting right here in Osage County, and I can see that I'm going to start the morning with 10 to 15 mile an hour, maybe 15 to 20 mile an hour southerly wind in Osage County, 45 degrees. And then as the day goes on, there's kind of this weak low pressure over here. You can see that's 1008, 1010, 1012, so there's a weak low pressure there. And it's going to move through and bring a wind shift in the middle of the day. And it's going to shift to a southwesterly wind. It's basically non-existent, 5 knots or less. And then as the day goes on and that low keeps moving through, eventually this north wind is going to come in and speed up a little bit. So if my morning stand setup is for southerly winds, I'm going to want to switch to a stand setup for northerly winds midday based on this forecast. And you can check this with a few different things. So you can go to the NAM-NEST model, which is pretty similar to the HRRR. It's not the same thing, but it's similar. But it does calculate things in a little bit different way. So it's good practice when you're using weather models to compare a few different ones just to see if they're all on the same page. And you're never going to get like an exact idea from this, from any weather forecast for that matter. You're not going to get an exact answer, and I'm sure you all know that. But, you know, we don't need exact answers when we're going deer hunting. We want a general idea of what things are going to do when we go out so we can be ready for that. But let's just go through the same process here on the NAM-NEST. And again, southerly winds may be a little bit stronger. You know, this is showing 15 to 20 mile an hour. Oh, wait, that's overnight. Excuse me. So here we are in the morning. This is 6 a.m. So 10 miles an hour around out of the south. And then there's that low pressure again. Moving in, and this is midday again. Got the wind shifting from south to kind of stagnant, maybe out of the southwest. And then as that low moves through, there comes that north wind with it out of the kind of maybe 5 to 10 miles an hour out of the north. And by this time it's dark. 2Z. That's like 8 o'clock this time of year, Central Time. So that's how you can kind of do a wind forecast, you know. And notice that these two models right now are fairly consistent between what they both think is going to happen with the wind and the low and stuff like that. But you do have times where they don't agree with each other, especially when it comes to like storms and you know, how much rain is going to fall in a specific area or how much snow is going to fall. That stuff can differ big time between two different models. So you know, you might be able to get away with just looking at one model and having a general idea when it comes to things like wind and air temperature and stuff. But if you're wanting to get a snow forecast or a rain forecast or anything like that, you know, you might want to look at a few different models to kind of get a ballpark. And just, you know, just a warning, they're is a rare blue moon? Well, they're all wrong, totally wrong. It rare doesn't happen very much anymore. Models are getting pretty good nowadays, but it does happen occasionally. So that's just something to keep in mind. And I've already kind of been talking about pressure, but the way you can look at pressure on these maps is just to look at these lines, the isobars, like I was talking about. And if you look down the lines every so often, you'll see the measurement of how much or how high or low the pressure is 1016, 1018, 1020. And this is in millibars. I know most people don't actually use millibars in their daily lives, but 1013 millibars is standard surface pressure. So if we want to convert that to inches of mercury, I know a lot of people use that. It's 29.9. That's kind of your normal sea level pressure. I want to say Oklahoma is around like 980 millibars. So, normal pressure there is going to be 28.9. This is something you need to look at for where you live because it differs based on elevation. If you're in the mountains, your surface pressure is going to be maybe 800 or less. So that's something you need to look at that's specific to where you are. And just to give you a basic idea, like I was talking about that low pressure system and telling you that a 990 is a pretty stout low in the United States. And they can get lower, but that's still pretty strong. And then 1030 is pretty strong high. If you get really, really strong cold fronts like the one that showed up on the GFS a minute ago, you can have some that are way up there. Like, where's that at? See, like this model is showing 1058. It's probably not realistic, and we're way out here in fantasy land on this model. If you haven't watched videos on the models before, about 200 hours, you're getting beyond the realm of realistic possibilities. And if you want something accurate, you really don't want to go beyond like 140 hours. But you can get a baseline idea of what things might look like between 140 and 200. But I really wouldn't trust this thing beyond 200. But we can go all the way out to 312 or whatever that is, a 1058 high. I mean, that's ridiculous. Let's 31.2. That's just not something you see very often. So, it's not impossible, but it's not likely. So, yeah. If you use this enough and go through these maps and look at all these, look at this stuff, for a couple weeks, you'll get used to using millibars. It's, there were a lot of abstract concepts in meteorology that took a while to stick for me, but I picked up on millibars fairly quickly in school, and I think you could too if you just use it for a couple weeks maybe. But yeah, that's that. And I guess I can look at a snow thing real quick. This is kind of the time of year where we get a lot of snow in the north, at least, and sometimes other places. But I like to use. Well, I really don't like to look at snow forecasts more than a couple days in advance anymore because it's really just, it seems like it's worthless. Like, I can come here to the GFS, go to snow accumulation, and, it's been showing for a while that we could get some snow in southern Wisconsin on Saturday. And, out to this range, it's not bad, but I'm not going to put a lot of stock in the actual amounts. The only thing I would even put money on at this range is yes or no, is there going to be snow, basically. And again, for snow forecasts, if you're going beyond 100 hours, you are throwing darts, pretty much. As a meteorologist, I can look at some other things, and have an idea of like, hey, maybe that'll drop some snow when it comes through. But like, as far as looking at these actual accumulation maps, good luck beyond 100 hours, and really good luck at 100 hours. Like I said, I don't like to look more than a couple days. This is at 48 hours. I can have pretty good faith that these areas up here are going to be getting that snow that's forecasted over the next 48 hours. But is there going to be 4 inches in southern North Dakota by Saturday? Who knows? I mean, this time of year, it's definitely possible, but will it be that exact amount? Probably not. So that's just something else you need to keep in mind when you're looking at this as well. And if you take this all the way out into Fantasyland again, the whole world gets snow, except the southern United States. So, I mean, it's like feet and feet of snow in some places, and that's just totally fake. So keep your wits about you using these models. But again, when I look at, I like to look at snow over the next couple days. And when I do that, I look at the HRRR and the 3K NAM, sometimes the regular NAM, and of course I do some of my own forecasting as a meteorologist, not using models, but just as a regular guy that doesn't have that kind of tools at his disposal. These are good resources, and this only goes out to 18 hours, and there's not a ton of things that can go terribly wrong in the model over 18 hours. I mean, it can be off, but like I said, this showed up in the GFS a second ago. It's showing up on this model, so I've got good confidence that there's going to be snow in northern Michigan, northeastern Wisconsin, and up around the Great Lakes over the next few days. So that's just how you look at snow. Pick a model, go to preset products, and hit snow accumulation. Now you want to use the Kuchera version of the snow accumulation model, because if you use the 10-to-1, 10-to-1 is realistic for certain parts of the United States, but Kuchera kind of takes into account like actual moisture content and things like that in the atmosphere that can have an impact on how much snow is actually converted from rain. Like this 10-to-1, what that stands for is 10 inches of snow for 1 inch of rain, which is definitely not the case everywhere. Some cases you have really dry, fluffy snow, and there's going to be a lot more accumulation with a little bit of rain than it was if it's like really wet snow, where it doesn't accumulate really high because it's not as fluffy. So the Kuchera model kind of takes those things into account, and I think gives you a better idea of how much snow will actually fall. So that's that. But yeah, so I guess I've given you the tutorial on how I go about making a forecast for hunting, and shown you a few things about the models. I know I've done this before, but I think this is really useful as a hunter. I look at this before I go out hunting every time, and it's been great for me. Obviously, when you go out in the field, you want to be taking powder or milkweed or cattails, whatever you can get, something that's really, really lightweight that's going to float on the wind as you walk. Take that out there with you. Throw it out every 50 or 100 yards, just see what the wind's doing. Make sure it's doing what you think it's doing. That's kind of that's how I do things. I mean, just because the models and the forecast says that the wind is going to be this way generally over this region, it doesn't necessarily mean it's going to be doing that at your exact spot. So keep that in mind as well. Because if you're hunting on the side of a ridge, you may have a west wind, but if you're hunting on the downwind side of that thing, chances are you're going to have an east wind, because it's going to be rolling over the top of it. And if you haven't heard of that concept before, you can come here to my website and watch this video here, and it'll give you a good idea. Well, I don't need the audio there, but you can get a good idea of what that'll actually look like when I show these things. Go and see how it comes over the top of this thing and circulates on the other side there. That's kind of how you get that effect. So go watch that video. That's another great resource for looking at things that have to do with the wind and how they change over different terrain features and all that good stuff. So, not to plug my own material, but you know, just wanting to help people out, and I think that video is pretty useful for that sort of thing. So, anyway, hope this is useful to you, and I'll see you next time. Come back in the keep coming back to the site and checking for more off-season material. You know, when I have free time, I'm going to be going out and doing some stuff and taking the camera with me. So I'm looking forward to it, and hopefully bring you guys some useful stuff.